Welcome guys. So in this video, we will use the mathematical induction and quickly prove the Bernoulli inequality. And I shall explain that the Bernoulli inequality will imply another important inequality in the future. Okay, so the idea is that we want to prove that 1 plus xn, x to power n, will larger than 1 plus nx. For x is greater than negative 1. And we will prove that this will implies this inequality. So this is a very famous inequality. This one. Okay, and actually this is for all the reals. This guy. Okay, usually in the computer science or our literature, this inequality is really interesting. Okay, so the idea is that I start from this, right? So the first one is that when x when n equals to 1, then it's just 1 plus x larger than 1 plus x, so it works, right? And the second is that we assume n equals to k is correct. So that means 1 plus to the k will larger than 1 plus kx. Third, that let's check what n equals to k plus 1 case. Okay, so 1 plus x to the n plus 1 is just 1 plus x to the n 1 plus x. So by using this, k plus 1, right? So 1 plus x to the power k will larger than 1 plus kx, greater or equal to 1 plus kx, 1 plus x. Right, so this guy is just 1 plus kx, x plus kx squared. Right, so it's larger than 1 plus k plus 1 x, right? Because k squared is always greater or equal to 0. Okay, so proof is done. Okay. Okay, so this is a proof why the Bernoulli inequality holds. So this inequality is easy. Okay, so let's take a look at how to get this. Okay, so idea is that we can take x equals to we can change x to x divided by n, right? So 1 plus x divided by n to the power n will larger than 1 plus n x divided by n. So this is just 1 plus x, right? So for all n greater than or equal to 0, so we can take n goes to infinity. So the left hand side will be exponential x will larger than 1 plus x. Okay, so one people may ask that why take because for each n, right, this inequality holds. So if you take limits, then this inequality must hold. Otherwise, that you can choose a large n such that it fails, right? So by the properties of the so there is a property that if an is also greater than 0, and the limit exists, then the limit will greater than or equal to 0. So this is the lemma that we will use, and proving this is also easy because, right, if the limit of an is non-zero, it's negative, right? So that means when n goes to infinitely large, large enough, then you will find an can be negative, right, for some n, which violates this assumption. Okay, so this inequality is so famous that people like to use. And also other people try to prove it. So I just use the Bernoulli equality and make a short video to prove both. Okay, I will see you guys in the next video. Be sure to subscribe to my channel. Thanks.